Okay friends, we have already seen how virtual functions can be defined. In this particular module, we will see how that can be put to use in a real sense. We have already seen the syntax, but then we will also pick up a typical case where virtual functions can make a lot of sense. Okay. So, we have already seen how to define and use a virtual function, and this model will see how one can put to use. Okay. We will see an example where it makes sense, and we will also see something called pure virtual function, which is a little different breed of virtual function. What is the difference and where one would use virtual function and where one would prefer a pure virtual function, we will discuss that as well. We will also see non-virtual non-member function, where it stands. So, as a designer, see, it is not only important for you to know that here is how you define a virtual function, here is how you define a pure virtual function, and here is how you define a non-virtual member function or non-virtual non-member function. You should also know which one makes more sense. So, when you are designing a system, which will you make a member function, which function will you prefer to make a pure virtual function, and so on and so forth. So, we will throw some light on that part as well. Okay. So, we are taking a specific case where one really need a virtual function. Now, here is a case where we have a video program, a video game, where you just moving along and there is an obstacle. Now, that obstacle is constructed on the fly, and we are going to talk about a case where the obstacle which is constructed on the fly is constructed containing 25 different shapes of some size and some type. Okay. So, it is very interesting challenge. Now, different types and shapes of obstacles are to be generated based on this base shapes, and here is where you can see that the virtual function makes a lot of sense. Okay. So, let us first of all see our definition of all the classes. We define a class called frame letter, but we need to refer to it. So, we have a forward declaration here. Okay. We have a class called point, where there is a constructor for that, and we have get x and get y, two functions to get the values of x and y, two coordinates. We are talking about a two-dimensional point, and we also overload this extraction operator for this thing, printing the point values. Okay. And it is actually get x and get y and just print those values. And this is something which I already have described. Video game needs random obstacle screen, which we are going to construct obstacles made up of random images, and these random images can be of any type. Okay. And that is the critical part. Images, in our case, we only restrict our images to 3 different types: triangle, rectangle, and a circle. Total 25 images used to construct a single obstacle. Okay. And now, the obstacle is defined as an object of class frame that we have already looked at, and we have a shape class, and from there we derive 3 different types of images, 3 different types of images: triangle, rectangle, and circle. Okay. And we also use a pointer to shape as a generic pointer, okay, to point to any one of those 25 images, can be of any different types. Okay. So, this is the problem. Okay. Now, what is the solution? What we do is we define an array of pointers of shape. Now, this is quite interesting. I want to have 25 different images, and the image like out of 25, maybe there are 10 images of rectangle, 10 of circle, and 5 are triangles, and so on and so forth. And which one is which, we don't really know. It is kind of a random mix that I am going to have. How will I represent such a structure? So, here the advantage is that I will define a pointer to shape 25 element array containing all pointer to shape will do for me. What I will do is, I just get what is the first object. is a triangle, then I say new triangle. Okay. A1 new triangle equal to new triangle, A2 equal to new shape, A3 equal to A2 equal to new circle, A3 equal to new triangle again, and so on and so forth. So, depending on the user's need or the random decision making process, I will just call new, get that object, and the P shape will point to that object. Okay. When I actually will be drawing that obstacle on the screen, I need to call that draw function, and that is the reason why I will define that draw as a virtual function. Okay. So, that is how this process is done. And remember, this draw will have to be virtual, because I do not really know A1 pointer draw is what. If it is a rectangle, then it will have to draw rectangle. If it is a triangle, it should draw triangle, and so on and so forth. So, it will have to be, that will have to be a virtual function. And here is a class shape, okay, and virtual void draw. Now, this is something we have already seen. So, I do not think I should describe it before again. A square also will have void draw. It will not have virtual word, but it is, as I said already, it is assumed by default. So, it is there, okay. And there are a few other things of this square. In fact, for square what I need to get is a left bottom as a one point, and then the length. I will be able to draw that entire circle. For point I need x and y coordinates. For square I need a left bottom and the length, good enough, okay. And triangle I need 3 points, okay. Using these 3 points I can draw the triangle. So, I am doing it. So, he is a constructor for triangle. So, this so far so good, simple. Circle class, I need a center and the radius. Once I get a center point and the radius, I will be able to draw that circle. So, again I have a virtual function here, draw. Okay. So, try to understand what we have already done. We have shape class, from where we have derived 3 different classes: square, circle, and triangle. Okay. I defined virtual draw here, I also defined draw in each of them. And now, when I have an array of pointer to shape, this is an array of pointer to shape, this may be pointing to a triangle, this may be pointing to a circle, this may be pointing to a square, and so on and so forth. When I write a code which A1 pointer draw, what will it draw? Will draw the object which is pointed to by that slot, okay, that pointer. So, this is the purpose, this is the process. Okay, how frame is constructed? Now, this is the code: shape pointer array 25, I call that array as images, array of images, quite rightly so. And here is a frame constructor. Now, please understand, I need some random values, because I like to fill that array with some types of images and some attributes of those images. For example, I will come with different circles where center is differently placed on the screen and the radius is different. So, I need 2 random values for a central point, because point need 2 values x and y. So, I need 2 random values for it and 1 random value for the radius. Similarly, triangle I need 3 different points, okay. So, 6 different random values, and for square I need 2 random values, 2 random values for the left bottom point and 1 random value for the length. When I will get those random values, I can draw any one of the images on any part of the screen, okay. So, for that I need that random function to be called, and if you know a bit about random function, you need to get the seed value, and based on that seed value, that random values are generated. An excellent method of generating random function is to randomize the seed as well. So, And a very simple trick done here is to call a function called time, which you just get the time from the machine that you are running on, and then use that thing as a seed for random srand. You just call srand with that, you get a random seed based on the time. Okay. And then you call this rand function. Okay. Rand 50 actually will get you any value between 0 to 49. So, what you do is, so for 25 images, now this is the array, you already have this array, p shape array is already defined. Okay. Shape pointer, these are all pointer to shape, this is 25 values, all of them are pointed to shape. Okay. Now, you get 6 different values 0 to 6, random values between 0 to 49 is generated, and you generate 3 different points P1, P2 and P3 based on those random values. Okay. Now what you do? Now again you generate one more random value between 0, 1 and 2. Now if it is 0, so now this is again random, so it is a triangle. This is 1, so is a pointer, the array that we were discussing about, the first pointer is triangle. If the second one is value 1, then it is square. The third one, if it is third is its random value is 0, again will be triangle. The fourth one, it is 2, then a circle, and so on. So, for all 25, the switch case will do what? We will pick up any random value 0 and 1, 2, based on that we will decide the image to be displayed, and then pointer is made to point to that after calling new with specific values which are again random. Okay. And now, this is an interesting thing, this is draw function of the frame class. Now, please understand our hierarchy does not include frame, our hierarchy is shape and 3 classes derived from it. Frame is a different class which embeds all these different types of objects. So, this draw function is neither inherited from it nor it is the same. So, it is not a virtual function, it is a normal member function of frame class. What does it do? Simple, for every image it just calls draw. So, the obstacle is just constructed. Okay. And because draw is a virtual function, wherever image is pointing to, that particular object is drawn at this point of time. Okay. So, the process includes using rand and srand function. Rand function will get you a random value, srand will set that seed value. Remember, if you keep the same seed value, the sequence of the random number generation will always be the same. Okay. So, that is very critical for you to understand, and that is the reason why we use srand with time value. So, whenever you run, you get a different value and you get a different type of obstacle. Okay. And what we do is we just fill array with random images, we just make it pointing to them. We just need to draw them, and actually the obstacle is to be drawn. Okay. And as I said, frames draw function is not part of the hierarchy, is a member function of draw, is not even virtual. And frames draw function calls every image is in a loop, it will calls the draw a1 dot draw, a2 dot draw, a2, a3, not dot pointer to, all of them. Okay. So, it will calls all those draw functions, those draw functions are virtual functions. Why not actually drawing objects? I have already mentioned that in the previous module. Because if you want to draw something specifically, you need to have a specific compiler for specific operating system, which we do not want to have. And obviously, here without drawing it, will just say that these are the values and the shape is drawn or circle is drawn. It is good enough for us to understand the functioning of virtual function. We do not really need to draw the function, and also simplifies our code. So, here are the reasons why we have not gone for the actual. What we need to do is we just define a frame and just say the frame draw and our job is done. All 25 images are randomly drawn on my screen in form of an obstacle. Okay. When I am using virtual function and doing something like this, it is called object oriented programming. Now, this is different than object based programming that we have already seen before. Object based programming was about using templates, function template and class templates. Object oriented programming is about choosing a function to call at runtime based on where my pointer is pointing to or where my reference is referring to. Now, these are different things. Object based coding, everything is resolved at compile time and you have no runtime overhead. Using virtual function of this type, the object oriented programming demands overhead at runtime, and that is the reason why one should use it cautiously, but then it will provide a lot of flexibility to coding, and if you need flexibility you may need to go for it. In some languages where this flexibility is considered to be sacred, for example Java, everything is virtual, every function is virtual. Okay. So, with every function you have a lot of liberty to as a programmer you have, but then they will not be able to execute with the speed with which you can get a C++ function too. So, for a typical need you will have to go for. The best thing about C++ is not that it provides object oriented programming or object based programming, but it provides you a choice as a programmer. Now, that point is very critical. I can use template if I wish to, I can use virtual function if I wish to, I am not forced to use it. If I want to use a normal member function, I can. If I want to use a virtual function, I can. If I want to use a template, I can. If I do not want to use it, I do not. If I want to define something as a member function and use it, I can. If I want to define something as a non-member function, I can. In fact, that is the flexibility a C++ programmer enjoys, and that is the flexibility that you have, a finer control that you have over that complete designing model, which otherwise you will not be able to have. Okay. Other languages, most notably Java is one of the best languages that we have, will not give you those types of flexibilities and options to work with. Okay, and that is where the C++ is considered to be good at. Okay. In our case, what we do is we just use a base class pointer, but here is what C++ does like Java. Function is a virtual function. There is a pointer which points to the base class, and whenever it is made to point to some other object of the hierarchy, depending on where it is pointing to, a typical function will be invoked, okay, based on that value. Okay. And you can write that code. For example, our case draw, you based on the object you can define draw, specific draw, and use it. Okay. So, that you can do. Object specific work, drawing a specific object is an example of object specific work, can be incorporated as a virtual function. The advantage is that I do not need to worry about where my pointer is pointing to, okay, and I can execute. The example that I have already given clarifies probably what I am trying to convey. Okay. Now, what is the other advantage of this object oriented programming? Suppose if I have one more class called hexagon added to this hierarchy. Okay, what should I be doing? Remember our code, I am getting some random this thing. I need to have one more case for hexagon and just call draw, 2 statements, done. I do not need to do anything. When whoever has designed hexagon class will contain the draw which he wants, and that is enough for me. Now, here is another point which I would like to clarify, is called designer and user issue. Somebody who has designed this hierarchy, somebody else would like to extend it, would like to use this thing further, would like to add a class to it, and would like to consistently use that class, then he will be given some requirements, like you will have to define a draw function in your class according to your need, and you will have to just do it, that is all. If I do that, see, if I am constructing all these classes as well as the frame class myself, and I provide that thing to somebody else, should I give him my source code? I do not need to. He can extend this hierarchy by providing his hexagon class, and once I provide those 2 extensions to the frame class itself, he does not need to do anything. In fact, it is also possible for you to remove those two statements, a little more complex coding, but you can do it. So, what he will have to do, he will have to just add that thing and provide his own draw function, and the same frame without any code change will work for him, will have an hexagon added to it. So, that is possible because of this design, and that is the power of object oriented programming, the extreme level of flexibility. If you need, you should go for object oriented programming. Okay. There are three different needs for such a design. First thing, generic things dependent on the design has to be there in the base class, because that is to be inherited in all other classes, and that is basically the idea of top level top down designing. Okay. Whatever the personal work of an object to be done is to be done in member function. For example, our constructors, square constructor will have its own information, length and the left bottom point. Point constructor will have its own constructor, and so on. Every class constructor is specific to that class object, and that is the reason why it is to be embedded in a member function. Okay. Other design bit constraints, but will have to be consistent, like draw, shrink, grow, kind of. So, suppose if you are using this thing, this images, shrink, grow will increase the size and decrease the size in some proportion. Okay. So, something like that is to be provided, will have to be done using a virtual function. So, without really knowing which object you are trying to, you are pointing, you can grow, shrink, draw that object. Okay. So, that work is to be defined as a virtual function. What are the overheads? There are two overheads. First, when you use virtual function, the first thing is you have a storage overheads for virtual function. Two overheads we have already seen for a virtual function, virtual table as well as the virtual pointer. Virtual table for every class, virtual pointer for every object of that class. And the other thing which is also very, very important, people do not address that thing in conventional C++ course, and I am also not going to do that. I will just mention that unless you have proper designing of virtual, non-virtual, member, non-member functions, you will not be able to take the complete advantage of the options available. Coding in C++ is comparatively more complex because you have multiple choices available to you, unlike Java. You have to choose precisely what exactly fit in a given case, and that is not always easy. Okay. The Scott Mayer's book, which I was referring to, is an excellent book in my opinion. The two books, one is called Effective C++, and the other one is More Effective C++. Excellent examples, there are 30 odd examples given in both of the books. You will have to just read and understand which feature is useful in which case. Okay. So, you may read that part. Okay. A few examples also are provided in my own book. So, you may refer to that as well if you prefer. Okay. Need for virtual destructor, I have already talked about that in the previous module, but let us try to understand. When we use a virtual destructor, the advantage is that whenever my base pointer is pointing to a derived class and I am deleting it, will delete the entire derived class which is inherited from, and not only the shape class sub object. Okay. What will happen if I have a case where if I have a case where here is my derived class and here is my base class pointer. Okay. So, if consider a shape case and I define shape. Okay. So, if I say shape as shape P shape and circle C and P shape, suppose this is the case. P shape equal to, I just say that new circle, something like this, or I will say that P shape equal to C. both of them will work. If I write something like this, later on if I say delete P shape, what will it delete? Will only delete the shape sub object of this circle object that is just created, or C. I have not used C and use new circle because I am talking about dynamic memory allocation process. Now, this is dynamically allocated. When I say new circle, I get memory good enough for holding an entire circle object. So, that I get, and later on when I say delete P shape, unfortunately what will happen is will only delete this part and not delete this part. So, some memory is released, but the other part of the memory is not released, and I have a problem. Instead of that, if I have defined this thing as virtual, when I delete this, will delete the entire object, will not delete only the sub object, will delete the entire object. So, there is a need for virtual destructor, okay, will delete what I want. And how you do it, whatever I discussed earlier, you can say this is my virtual destructor. Is my virtual destructor. I have all virtual destructors, and now okay, I can even write a destructor for my frame. When I say frame is destructed, goes out of this thing, will delete images I, will delete memory worth of all images that are allocated before. That is the power of virtual destructor. Okay. We will talk about something called pure virtual function. As I have already mentioned, pure virtual function is where you just write virtual function, pure virtual function name equal to 0, that means it is a pure virtual function. The difference between virtual function and pure virtual function is not a very different thing. Here you can see that virtual void draw equal to 0. There is no body in the class. You can actually define the body outside the class, like we have already seen before, is usually not done. Okay. How will you use this? But anyway, what is the difference? Let us first of all understand what the difference is. When you define a virtual pure virtual class, there are two things. First, the class will not have any objects, and such class is known as an abstract class, and usually in top down design, bottom up design, sorry, usually the class, the base class does not have an object. So, it is not a big deal actually. The second thing which is very important, unlike the earlier case, if you define a virtual function in one class and do not define the virtual function in the inherited class, the earlier virtual function class will be called, the base class virtual function will be called. In case of pure virtual function, every class must implement that pure virtual function in itself. If it fails to do it, the class becomes an abstract class, you cannot define an object of it, that is the difference. Okay. Here is an example of class called error. Okay. Now, here is a class link error which is inherited from syntax error, okay. And I have commented this part, that means there is no solution function, okay, which is basically a virtual function. So, what will happen? This is a virtual function. So, if you fail to define a virtual function, is not an error in the context of C++. If I ever call a link error class object with draw, with this if solution, the output when not commented, what will it do? We will call the parent class. Parent is a syntax. So, we will call the syntax function. Okay. Simple. Init and linker. If the pure virtual function commented, error, the program will not compile. Output when commented, you get the syntax, the base class. Okay. So, that is the difference between pure virtual and virtual function. The advantage, see, pure virtual function for our case like draw, pure virtual function is a little better choice. Why? Because if you use a pure virtual function and you give me a hierarchy, if I define a new class, I will have to define draw function myself, I cannot escape from doing it, as is a rule for pure virtual. If I fail to do that, I will not be able to instantiate objects of that class. So, I will have to do it. Okay. So, you can see that for draw it is compulsory. In case of error normal virtual function is little better. Why? Because in case of an error class, if I cannot display an error of a typical class, the parent class error is good enough. If I do not get a linker error, if I say that there is some syntactical error, it still make a lot of sense to a reader. So, in some cases virtual functions are fine, in some cases pure virtual functions are fine. As I have told you earlier, it is all boiling down to your design and your requirements. With that note, we will conclude. Let us see what we have seen in this particular module so far. We have seen how to implement virtual functions in this particular module. We started with an example of obstacle being generated from 25 images, random images. We took an array of 25 images, a pointer to shape basically, and we construct those images using srand and rand functions in a random case, and generating a random obstacle. And we can see that virtual function makes a lot of sense in such cases, because in the frame class we will just use images and draw. We do not really know what those pointers contain, but whatever they contain, that will be drawn. So, that is the power of virtual function. After that, we will see, we have seen how to define and use a pure virtual function, which is very similar to the virtual function, with only two differences. Whenever you define a pure virtual function, the base class will not have any objects of it. This is called an abstract class. Every inherited class must implement pure virtual function if it wants to have an object of itself, otherwise it cannot. Okay. So, that is the difference here. Sometimes this difference is denoted as implementation versus interface difference, but anyway I will not be discussing about that much. Again, the reference, Scott Meyer's reference, will throw a lot of light on it. I also have discussed about them in my own book. So, you may refer to any one of them to understand more about the difference between a pure virtual function as well as a virtual function. With that note, we will conclude. Thank you all friends.